Welcome back to our channel, where we dive deep into the world of modern maritime navigation. Today, we're tackling a scenario that's becoming increasingly common and critical for every deck officer, transiting an emission control area, or ECDIS. These zones are established to protect human health and the environment by setting strict limits on airborne emissions from ships, particularly sulfur oxides, nitrogen oxides, and particulate matter. Getting this wrong can lead to hefty fines, vessel detention, and a serious blow to your company's reputation. So, let's set the scene and explore how to navigate these areas compliantly using our trusty ECDIS. Imagine we're on the bridge of a large container vessel, mid-voyage on a transatlantic passage from the US East Coast to a major European port like Rotterdam. The weather is fair, the seas are moderate, and we're making good time. Our next major waypoint marks the entry into the North Sea ECDIS. This is where meticulous planning and precise execution become paramount. It's not just about steering the ship anymore. It's about environmental stewardship, and our ECDIS is the central tool for managing this complex task. Months before we even cast off our lines, the voyage planning process began. The second officer, responsible for passage planning, laid out the entire route. A crucial step in this process is the route check function on the ECDIS. When the planned route was created, it crossed the boundary of the North Sea ECDIS. The ECDIS, being the smart system it is, automatically flagged this. An alert popped up, notifying the planner. Caution, route enters an emission control area. This isn't just a simple notification. It's a critical trigger for a series of operational procedures. This initial warning ensures that from the very beginning, the entire bridge team and the engineering department are aware of the upcoming environmental compliance requirements. With this alert, the second officer then activated the relevant layers on the ECDIS. Specifically, they overlaid the MARPL and ECDIS special area layer. Suddenly, the ECA boundary wasn't just an abstract line on a chart. It was a clearly delineated zone on our primary navigation display. We can see exactly where it starts and ends. The ECDIS allows us to customize the display of this area, perhaps with a distinct color or hatching pattern, making it impossible to miss during watchkeeping. This visual reference is constantly in front of the officer of the watch, serving as a persistent reminder of the changing regulatory landscape we are about to enter. It transforms the chart from a simple navigational tool into a comprehensive operational and compliance dashboard. Now, let's look at the passage plan itself. The ECDIS-generated passage plan is more than just a list of waypoints and courses. It's a detailed, time-stamped schedule of events. Integrated within our plan are specific notes and alarms tied to the ECDIS entry. For our voyage, the plan includes a critical action item: commence changeover to low-sulfur fuel. This isn't just a vague instruction, it's a calculated event. We know our vessel's speed, and we know the distance to the ECDIS boundary. The plan has a specific waypoint or a time-based alarm set several hours before we cross the line. This alarm prompts the bridge to notify the engine room to begin the fuel changeover process. Why several hours before? Because switching from standard heavy fuel oil to compliant low-sulfur fuel isn't like flipping a switch. It's a gradual process that requires careful management by the engineering team to avoid thermal shock to the engine components and to ensure the entire fuel system is steadily flushed of any non-compliant fuel. The logbook entry must be precise. The chief engineer will record the exact time the changeover procedure was completed and the fuel oil tanks that are now in use. The time and the ship's position recorded on the bridge must correspond perfectly with the engine room log. The ECDIS provides the precise position, ensuring our records are synchronized and accurate for any potential inspection by port state control. So, the alarm sounds on the bridge. The officer of the watch acknowledges it and immediately contacts the engine control room via the ship's telephone. Engine room, bridge. We are commencing our approach to the North Sea ECDIS. Please begin the fuel changeover to low-sulfur fuel as per the passage plan. The engineering team confirms and starts the procedure. On the ECDIS, the officer can create a user-defined event, a digital pin drop, marking the exact position and time the instruction was given. This creates an indisputable digital record. Throughout the changeover process, there is constant communication between the bridge and the engine room, confirming progress and the final completion of the switch. Once the chief engineer confirms that the main engines are running solely on compliant fuel, another log entry is made. The bridge team updates their own records, and a note is often added to the ECDIS log. We are now fully compliant, well before crossing the invisible line in the water. As we continue our passage, the ECDIS remains our primary tool for monitoring. The active route clearly shows our vessel's icon moving closer to the ACA boundary that is so clearly displayed. There is no ambiguity. Every member of the watch can see our position relative to the zone. As we finally cross into the North Sea ECA, it's almost an anticlimactic event on the bridge, and that's exactly how it should be. The smooth, seamless entry is a testament to the detailed planning and the effective use of our onboard technology. The ECDIS continues to log our track, providing an unbroken record of our compliant transit through the area. During the entire time we are inside the ECA, we are operating on the more expensive but environmentally friendly low-sulfur fuel. All our emissions are now within the strict limits set by MARPOL. The monitoring doesn't stop there. The ECDIS helps us maintain our situational awareness. If, for some reason, we needed to deviate from our planned track, perhaps for a traffic situation or a weather avoidance maneuver, the system would continue to show our position relative to the ACA boundary. If the deviation were to take us out of the zone temporarily, the entire procedure of logging and potentially even fuel changeover would need to be considered again upon re-entry. The constant, clear visual display on the ECDIS prevents any accidental non-compliance. Finally, after a day and a half of steaming, we approach the other side of the North Sea ECA. Our passage plan, once again, has a pre-planned point and alarm for exiting the zone. At this point, the reverse procedure can be planned. The bridge will notify the engine room when it's clear to begin the changeover back to conventional, more economical heavy fuel oil, but only after we are completely clear of the ECAS jurisdiction. Again, all times, positions, and actions are meticulously logged. So what's the outcome of this carefully managed scenario? The vessel successfully transited the emission control area in full compliance with international and regional environmental regulations. Our records, the ECDIS track log, the bridge logbook, the engine room logbook, and the oil record book are all consistent and provide a clear, auditable trail of our actions. When we arrive in Rotterdam, and the port state control officers come aboard for an inspection, we can present our records with confidence. They will check our logs, they may even take a sample of the fuel currently in use, and they will find everything in order. The result: no fines, no delays, no detention. The vessel maintains its schedule, and the company upholds its commitment to environmental responsibility. In conclusion, navigating an emission control area is a perfect example of how modern navigation has evolved. It's a multi-departmental effort coordinated from the bridge, with the ECDIS serving as the central hub for planning, execution, and monitoring. By properly setting up our ECDIS with the right layers, using the route check function, and integrating operational procedures into our passage plan, we can ensure a safe and compliant voyage every single time. It's about using technology to be better, smarter, and cleaner mariners. Thanks for watching. If you found this breakdown helpful, be sure to hit that like button, subscribe for more content on maritime operations, and ring the bell so you never miss an update. Let us know in the comments if you've had similar experiences or if there are other scenarios you'd like us to cover. Until next time, fair winds and following seas.